So hello, today we're going to work in this video specifically on the population model, how to make a polynomial model and how to make an exponential model. So the first thing you'd want to do is set up a Google Sheet, and as I told you guys in class, we need to basically get this data by decade. You might be able to find a nice data set that has to do with your region, and you might not necessarily find something that easy to use. So if you can copy some columns over, that'd be fine with me. In the case of the data set I found for France, I have a list of numbers that I'm going to show you. So I went to this site called Statista, and on this site I made an account, so I was able to download the Excel files. If you need help with this, I could try to help you. Come find me during class, after school, lunch, all those different times, and we'll talk about how to, get you guys the correct data that you need. But you should recognize when you look at a site like this that the data is in thousands. If you notice on the site, it says population in thousands. So this is not, in this case, representing, say, 40,000, but 40,000,000, which would mean 40 million. So that means you have to add an extra 3 zeros to each one of these numbers. Now I downloaded the data file, so like I said, I made my own spreadsheet, but then here I have the data that I downloaded, so I can help you guys get this and work with that. And in this case, the data didn't break down so nice and easy. I wasn't able to get this column so that I could copy it and paste it in there to make life a little simpler. So in this case, I'm just going to have to do the work of copying over the numbers. So you can see that this says 30,462, and because the population is listed in thousands, so what that means is that this number right here represents 30,462,000, so that means you have to add 3 more zeros, which basically means this is a little over 30 million. So I'm going to go enter that number into the spreadsheet, so I'm going to put 30462, and then I'm going to add 3 zeros, as I said, and then I'll do the next row. And so because I have 1821, that's fine in this case. I'll just put it under the row for 1820, and if I have time, I might be able to go in there and change these numbers out to be more specific. But for now, as I said, the population doesn't change so much every year, so just get every 10 years would be fine. So now I'm going to take 32,569, so I'm going to go 32569, and then I'm going to add 3 zeros onto that so that I have this this next value, right? So you can see 32,569,000. So now I'm going to go look for the next one, which would be 1840, and I can see 1841 has 34230, so I'm going to go back and get 34230 and then add 3 zeros on there. Okay, and that value should be there also. So now I get the next one. We get 1850, and I see 35783. So I'm going to go right 35783, 1, 2, 3. And this would be something that you should be able to finish in one class period. So now I'll go to 1860, 37386. 37386, and I'm adding 3 zeros every time because that's what this data set calls for. So now I go to 1870, and I see 36103, so I'm going to go type that in as 36103. Okay, if I don't adjust these years, obviously this is like a population estimate, which is fine, and you can see that in this case I forgot to add the 3 zeros, so you want to do that every time to make sure that your data doesn't jump around too much. Let's go double check that 1870 because it looks like it went down a little bit, so maybe that's true, maybe it's not. Let's see what happened. 1872, we had 36103, and it was more before. So that tells you, something must have happened. There might have been some kind of reason to explain why the population dropped. And that's part of why I actually wanted you guys to look at such a long period of history, to give us a chance to find some fluctuations. So it looks like I did that correctly, so we'll go on to 1880. 37406. So I hope, and then 1, 2, 3. So I hope you guys are seeing, the process I'm going through. So what I'm going to do is pause the video and I'm going to go add in the rest of the values. So I'm almost done with my data set now. I inputted all these values. To get to the last set of values, the table didn't seem to have everything, so I went back to the chart and just put them in looking at this. So 2020 would be fine. Like I said, just get one number for each part of the decade. And so here we got 2020 says 65273. So I'm going to write 65273 and then 123. So there we go. So the very next thing that I would do is set up my chart, and I'm going to select these two columns. So I will zoom out a little bit so you guys could see what that'll look like. I will select these columns, and then I will go to Insert Chart, and now you can see I have a chart. So what we're going to do is go to Chart Type, and I'm going to select Scatter Plot. So scroll down through this, find Scatter Plot. Then the very next thing I will do is go into Customize. Looks like we have our data set. You might have to mess with it to make sure that the x-axis is your A column. So notice that the x-axis should be your dates, and that the y-axis, what it has under series, should be the B column. So just say B1 to B21. So you can see we have those 21 rows of data. We have a scatter chart under Setup. So now I'll go to Customize and look under Series. Now under Series, I will scroll down to Trend Line. Alright, we've done this before, and we don't want to have a linear model, right? In Math 1, a linear model might be something that, would be good to study, but because we're doing so much polynomials, I want you guys to make a polynomial model. So we'll make two models. I asked you guys to make a polynomial model and an exponential model. So we'll make we could make the exponential one first. Either way, it doesn't really matter as long as you have your slides together. If I jump back into this assignment, you can see that what I have right now is the Google Sheet table. So that's one thing checked off the list. And now I need to make an exponential model and a polynomial model. If we go in order, I guess I'll do the exponential model first because that comes first. So let's go ahead and do that. So we'll go here and select exponential model. You can see that it actually has a curve. It looks still pretty straight, but you can see the line changed. Again, look at how it changed. It's no longer a straight line. You can see that it curves. So exponential graph has a curve to it. We're going to select Use Equation, and that will give us this equation right here. That is the equation for our exponential model. So again, under Series, we have our equation. We have all the things we need. We could click on this text box, and we could try to make the font size a little bigger so that you guys can see it. So let's select a bigger font size so that it's easier for you guys to see. And when you get into Google Sheets, you guys will see something about this. Okay, the exponential model uses this special number called the exponential, and so that's E. And if you were to Google the number E, you'll see that it's a special number with a very complicated, at least for you guys to understand now, it has kind of a complicated value, okay? But if you look it up, this is a very well-known number. They use it in science. We use it all over the place. And the value is about 2.7182818, and it actually doesn't repeat. You can see it looks like it's going to repeat, but it actually breaks away. And the pattern, it's an irrational number. So this number is very, very important. It's a very deep number. It's very useful. And this would be the base of our exponential function. So you would be able to see here that this is the equation. So we'll talk about that in a second. In fact, we could go to Desmos and we could type this in, and we could figure out what's happening here. But don't forget again the scientific notation. This e to the negative 0.3 means that we would have to move the decimal point 3 times to the left to get this value. So again, I'm just trying to show you guys how to get the graphs. So this would be your exponential model. Would basically be done. And now what you could do would be to take a snip of this, right? take a screenshot of it. However it is that you want to use this, you could take a snip of just this part, and then maybe what you could do is put this into your slide and add a better label, right? So take a screenshot of that, save it, and then go add it into the Google slide that will go to, as we said, the exponential model, right? So there's going to be a slide, 3 Google slides, as I said, an exponential model, the polynomial model, and then one slide will compare the two of them. So we would be able to take that screenshot and use that for this one. But now what I'm going to do is go edit my model. So when you want to change it, you go into edit chart, and now back to customize and series. And then what will happen is we'll scroll down to, instead of type exponential, we'll pick polynomial. And as it is, it's a polynomial degree 2, which means a quadratic function right here that they're trying to use to find the best quadratic function that would explain the most of this data. Okay, so one thing that I forgot to mention is that we did this last time where we included the R2 value, this R squared value, okay? And what R squared does is tell us what percentage of the data is explained by this function, like how close does this come to explaining all of these data points. And so this number 0.968 means that 96%, 96.8% of the data is explained by this, which is pretty good. But I actually want you guys to have a better, a higher degree polynomial, so I would tell you to either use degree 4 or degree 6 at least to make sure that you have something that explains your data to a higher level. And so you can see that when we use this, this value, we get something that explains 99.3%, which is much better. And you can see we have the equation up here in our label. So this would be the polynomial model, and again, that's a 4th degree polynomial. So now what you would do is you would go take a slide and, you know, snip that. And I kind of taught you guys how to deal with the scientific notation and everything like that, so how to use Google Slides to actually write a label. So I would kind of encourage you to take that label and, you know, write this in a regular font when you make a sheet about this. I'm sorry, when you make a slide about it. For instance, I could show you what I mean. Say I go into the sample presentation that I made, and I get in here, and what I will do is create a new slide. And, you know, I could drop my model in here, but as I said, I wanted you guys to have like a more like aesthetically pleasing formula, right? So I taught you guys how to do like an exponent, right? So you do X and then control period, where you type the actual 4, as opposed to the way it looks here, where it just has a little up caret symbol. We would want you to, you know, make it look a little better. And then you can see most of these numbers aren't really in a, you know, well, some of them are in scientific notation and they're pretty big. So maybe you could keep some of them in scientific notation. So, you know, just mess with the font, put it together, and make your slide, you know, have a label that makes sense with the equation that represents the data here. So you would want to put the equation at the top. We might be able to copy and paste this equation. If I just press copy and then jump over here and paste it in, you can see that the difference is that I don't have any of my exponents in superscript, right? And so by superscript, we want that exponent to actually be available so that we can see it. So what I'm going to do is go back here and then press control period and then 2, right? So that we look at it as like an actual exponent. And press control period 3, we have that term, and now here the same thing, control period 4. And you know, this just looks a little better than it did a second ago. And then we could even label this as f of x. We could even call it f of t, whatever you guys want it to do, to show that it's a function of x being the years, and you know, the f of x value represented by the population. So this would be our polynomial model. So then what you would do is, you know, put a text box, put a label it as a polynomial model. I don't want to get too much into the aesthetic part of your graph, okay? But polynomial model, population of France, right, from 1820 to 2020. All right, so something to this effect. And then, you know, obviously I'm trying to do this quick for the video so that you guys have an explanation of how to do this. So, like I said, we want that r squared value also to be here, and I think that would be something that you could include in the comparison slide, right? So, you know, this would be the polynomial slide. Then you guys would have to include the exponential slide. And as I was telling you, comparing the two basically comes down to that number, the r squared value. We can see that the polynomial model has an r squared value of 0.993. So, you know, there will be an exponential model slide, in which case I would take a screenshot of this being switched to exponential. So if you lose that and you need to get it back, that's what you would do, is go to edit chart and get that. Okay, what I'm going to do is use this r squared value of 0.993 and put that down. I want to make a new slide. Alright, and then put comparing exponential and polynomial models. And then I would be able to write something about the polynomial model. R squared, the r squared value equals 0.993, which means it explains 99.3% of the data. The exponential model has an r squared value okay, the exponential model r squared value was still decent, but it wasn't as good, right? So we can go look at what that was, right, just to kind of review how to do this, right? So we'll go to edit chart, and I'll go back to customize and series, and then I'm going to change this model, the trend line, from polynomial to exponential, okay? And so we see our value right here is 0.923. So when I go in here to my thing, my slide comparing them, 923, and then we'll put like a little explanation, right, which means it explains 92.3% of the data. Okay? In this case, the polynomial model is a better model because it explains a higher percentage of data. Okay? And this is because, why is that? Okay, if we go back and look at our model, we can see that the exponential model is not able to capture the idea of going up and down. It fits the overall trend, starts here and ends up here, right? But it's not able to deal with the fluctuations, the way that it went up and down a couple times in this time period, right? So we can see that was a big difference. Like the polynomial model can increase and decrease, right? It can fluctuate, it can go flat, it can like go back up. Because it's a higher degree polynomial, it's able to do that. If I was to increase the degree to 6, we'll see that it's going to fit even better, and you'll start to see more fluctuation that it can explain, right? So the higher that you explain that, you know, sometimes your model can get overfit by the data, such as here, when I go to 10th degree polynomial, we see that the data, our model overfits is what we would say, and that it gets too much. All right, but again here, look at 8. Degree 8 is actually pretty great. And if we were to look at this r squared value, we would probably see an increase in that r squared value, right? We can see that it's 0.996, which isn't that much better, but it's still better nonetheless compared to the 4th degree polynomial of 0.993, right? So there we go. There you have it. This is the way that you would get your polynomial, your exponential models. As I said again, there has to be 3 slides, so, you know, to be able to go back and get my exponential one, I'd say, okay, let me go take a screenshot of this one, and then put that onto a slide, and then just try to note any specific changes. Alright, I'm doing this kind of quickly so that this video doesn't run on and on, but I hope you guys understand this process at least, and then you can help your partners get through this part, right? So as I said, try to make the slide look good so that we can have something that we learn about it. I think some of you guys have maybe even been studying this period of time where there's been a little bit of maybe some problems, so maybe you guys could even explain quickly why there is a population fluctuation. In this case, some of you guys might be dealing with France, so I'd like you guys to still go ahead and do all the work, create the sheet and everything, right? So as I said, we'd have a model of polynomial, an exponential model. You can put them in the other order if you want, so if they're in the order of the checklist, and once you get that, you'll be able to compare them. And as we said, this is because the polynomial model is able to capture the changes of let's go ahead and set a change, let's say the increase and decrease. See, the exponential model really was only able to explain the increase, but it didn't really help us explain the times where it goes back down. You can see that in this part, the model doesn't really adapt to that. It fits through like it's a good average. Again, it's 92% of the data, but it's not perfect, right? So this is me explaining the population model. I hope you guys understand, 20-minute video, trying to make it quick. If you have trouble getting data, then I would recommend, registering for a website, trying to find the best data that you can, searching around. Again, 20 rows of data, it's not that much. You guys are in high school, so I think you guys could deal with this. Let me know if you're having trouble finding the data, and I'll do what I can. Alright, good luck guys on the project.